So as we start something, in this case trigonometry is a course, we're going to start with one of our basic units in trigonometry, and that's an angle. And defining this, we're going to have two rays in a plane with the vertex at the origin and the initial side on the positive x-axis with the terminal side theta units from the initial side. Everybody got a picture of this angle now? Right. One other thing you need to add, another sentence here, is this angle is in standard position. And so part of what we're trying to do is we're trying to say to everybody, when we talk about something, when we maybe talk about a 30-degree angle or a 70-degree angle, that everybody's going to think about exactly the same shape in exactly the same location. That's the point of having a standard position happening with our angle, is we each say the same words, everybody gets the same picture. And so that'll be kind of important. Are there any words within this definition that you're saying, I don't know what that is? Standard position. Well, the descriptor is we're going to start with the initial side on the positive x-axis, and then the terminal side is theta units from that. And so standard position means we always start in the same way. So let's start drawing out what some of these words are to try to help us out just a little bit. So it mentions two different rays. And it says that the vertex is on the origin. So I'm going to start my ray here. And if I go along the positive x-axis, this is the initial side. So every time we do this, we're going to have one side of our angle be right there along the positive x-axis. Okay. Even number bigger than
105.
105, that works. All right. So if we have a 105-degree angle, that means from our initial side, we're going to need to move in the positive direction, which turns out to be counterclockwise. This is your positive direction. And so then when I put the ray over here to represent that angle, where there is theta as an angle, that's what it means. This over here is your terminal side. Yeah. Has anybody ever flown in an airplane?
Yes.
Okay. Once you have the airplane land and you're ready to get off the airplane, where are you getting off the airplane at? You're at the terminal. That's an ending side. I know. When you get on the plane, you're getting on the plane out of the terminal, but bear with me, okay? Do the one side of that conversation only. But hopefully that idea of the word terminal will be ending side to you. So if I'm implying that if I go this direction, that's a positive direction. What would happen if I said, let's go this direction? It is negative direction. So think about for just a minute, could you draw a negative 255-degree angle?
Yeah.
What's it going to look like?
A 105.
The same as your positive 105 that we just had, right? So if this is positive 105 and this is negative 255, they're at the same spot, right? We call those co-terminal, meaning they end at the same spot. But you have one that's positive, one that's negative, and they're known as co-terminal angles. Does that make a little bit of sense? Well, let's see. Anybody still need anything on this image? The next image we go to, we're going to go back to this quadrant system. And I want to kind of write in the degree managers in the positive direction going around that happen at each quadrant ending point. So right here is 0 degrees. That's kind of where we start. And as we go through the quadrant 1, going this way is a positive angle, we stopped right here. Where is that boundary line? Yes, that is 90 degrees. Let's say we continue on around. Where does this stop here? Okay, we continue around. Where do we stop here? And then we keep going. We're here. Where do we stop? Okay, we keep going. Where do we stop with up here? You keep going. What do you stop with here? Okay. And then we can continue on, correct? Does that make a little bit of sense? Okay. What would happen if instead of going in the positive angular direction, we went in the negative angular direction? If I went this direction here, so the blue goes this way. What am I at right there? What am I at right here? What about up here? And then over here? And if I kept going, what would this one then be? Negative 450? Okay, does that make some sense? So let's see what we can do with that. Please hold up an appropriate number of fingers. I'm going to name for you an angle measure, and I would like you to name for me the quadrant that it's in. You know, before we do that, we probably ought to label our quadrants again, right?
No, 2.
Yeah, we ought to name our quadrants to help us remember. Quadrant 1 is here. I mentioned that. I would like you to use Roman numerals to name our quadrants, by the way. As we continue on through, where is quadrant 2 located? Now, wait a minute. Positive angle goes this way, correct? It goes up through quadrant 1 and it goes into quadrant 2 as the second thing, right? Where's quadrant 3? So as we continue on around with our positive angles, and then finally this is quadrant 4. Does that make a little sense?
Yes.
Back whenever you first learned about these quadrants, were you kind of wondering, why did we number them that way? Does it make a little sense as why we numbered them that way? Okay. Math, that's a good thing. So in what quadrant does an angle 225 degrees land? Put an appropriate number of fingers in the air. What quadrant does an angle of 225 degrees land in? 225. Should be a quadrant 3 because it's between the 180 and the 270. Okay? In what quadrant does an angle of negative 100 land? Negative 100. That's also quadrant 3. Okay? Now let's think a little bit more. In what quadrant does an angle of negative 500 land?
Negative 500?
Negative 500. We're thinking about it now. Which direction do I go? We go this way, right? So if I work my way around, if I go all the way to here, that's negative 360. We keep going, we know that's negative 450. We keep going, and we get to here, and we say that's negative 540. So it's somewhere between here. Still quadrant 3. I haven't moved us out of quadrant 3 yet. You understand that? Okay. And I hope in that little bit of conversation you saw, how do we need to start thinking about this? Sometimes just work our way around. Okay. Let's do some positive angles again. Let's do positive 315 degrees. In what quadrant is 315 degrees? That's quadrant 4. In what quadrant is 400 degrees? That is quadrant 1. 400 degrees is quadrant 1. It's here between the 360 and the 450. All right? Let's see, what was one that I picked out earlier? In what quadrant is 1050? Error. Overflow. 1050.
Quadrant 5.
Okay, let's talk. Let's talk about it real quick, okay? We know 1 time around is 360. 2 times around we know is 720. 3 times around, 1,080. All right, you remember a 1080, if you pay attention to snowboarding and stuff like that, a 1080? That's 3 loops. Oh boy. Well, 1,050 to 1,080, that's a quadrant 4. Okay. Some of you I know can relate to the snowboarding or skateboarding or donut driving, whatever.
What?
Making donuts. Well,
Yeah.
anyway, not that we want to know about any of those things. Do you have any questions? Yeah.
Well, how can you draw like a 520?
Awesome. That's a great question. Did you hear it? How would you draw a 520-degree angle? I think that's an amazing question.
You just keep going and pretend it's there.
All right. That's actually what it is. We know that we go around 1 time and make kind of a spiral loop. That's 360. We know, you said 520?
Yeah.
So we're about to right there on our second loop. We have to be able to count how many loops, and then we would draw that thing, and we would even label it 120 degrees. But you leave that loop, that spiral in it, that lets us know that, hey, that goes around more than once. Okay? Any other questions?